Thank you for listening to our presentation. My name is Masoud, and I'm going to talk about our paper titled Is Implicit Authentication on Smartphones Really Popular? Let's start with a quick background overview. Smartphone unlocking is shown to be perceived as a burden by users. They unlock their devices at least 30 times per day, and each attempt takes between 2 to 3 seconds to perform. For short sessions, this can be an 80% time overhead. And this increase in the cognitive and physical overhead of using the device creates incentive for the users to weaken or disable authentication on their phones. And consequently, studies have shown that between 10 to 45% of smartphone users do not use any locking mechanism on their phones, citing inconvenience as the reason. To address this problem, researchers have proposed implicit authentication, which is a method of authenticating smartphone users by leveraging data that is available implicitly and without requiring any explicit user input. Types of data that can be used for IA include behavioral biometrics, such as the way that you interact with the touch screen of your phone or your biomedical signals, or contextual data, such as your location or your surrounding Bluetooth devices. IA is shown to be a promising technology to alleviate the smartphone unlocking burden because it can actually reduce the amount of effort needed to unlock devices. However, the perception of IA by normal smartphone users is rather understudied. A few existing studies suggest a strong adoption interest in the technology. For example, one study by Crawford et al. Showed that 90% of their participants were interested in adopting IA. Another study by Khan et al. Showed that 63% of their participants were interested in adopting the IA technology. These studies, however, are of limited generalizability. Firstly, they use low-fidelity prototypes which often do not suffer from authentication false positive or negatives. And secondly, they are often conducted in lab environments, which raises issues with ecological validity. Our goal then was to conduct the first large-scale IA perception study which does not suffer from these issues with generalizability. To conduct such a study, we evaluated how a smart lock for Android is perceived by Android users. Smart lock is the first widely deployed IA scheme available on most Android devices. It provides three different methods of authenticating users. The first one is called body, and it allows you to keep your phone unlocked for as long as you are in motion. The second one is called place, and it allows you to unlock your phone at certain designated locations using the GPS signal. And the third one is called device, and it allows you to automatically unlock your phone when it is in the vicinity of a certain Bluetooth device. What we were interested in was to first understand how widely a smart lock is adopted by Android users, and secondly, what the factors are that attract or deter potential users from adopting smart lock. To answer our research questions, we conducted a mixed method study. We started by conducting a cognitive walkthrough with users study, which involved 2 cognitive walkthrough sessions with 10 HCI proficient participants, followed by 16 Think Aloud Plus interview sessions with normal smartphone users. We then used thematic analysis to analyze this data and form a series of preliminary hypotheses about our research questions. We then conducted an online survey on Amazon Mechanical Turk involving 343 Android user Turkers to further verify our hypotheses. To analyze our data in this study, we used Friedman and Durbin-Conover tests. These graphs show the demographic distribution of our survey participants. As it can be seen, our sample was fairly diverse in terms of gender, age, and education. Furthermore, our statistical analysis showed that the distribution of demographics in our sample was not statistically significantly different than the general smartphone user population in the United States. Therefore, we believe our sample to be fairly representative of that population. Let's first talk about how widely a smart lock is adopted. This chart shows the number of our survey participants who were adopters or rejectors of each smart lock method, or in case they did not have any experience with that method, whether they showed interest or uninterest in adopting it. Based on this data, we calculated an adoption, a rejection, and an interest rate for each smart lock method, and then we obtained an overall average. As it can be seen, the smart lock has a relatively low adoption rate of around 14%, and it also has quite a high rejection rate of around 22%. And when compared to existing IA perception studies, the interest rate in a smart lock is lower than expected at around 44%. Naturally, then, the question becomes why. To answer it, we asked our survey participants to rank, in order of importance to them, the reasons as to why they decided to adopt or reject each smart lock method, or to show interest or uninterest in adopting it. These spider graphs show the average importance score that participants assigned to each category of reasons. For this presentation, for the sake of time, I will be focusing on three important categories, namely security, utility, and reliability. If you are interested in reading about the other categories, please refer to the paper. Let's first talk about security, or rather lack thereof. Insecurity was a deal breaker for our study participants. They ranked it as the most important reason for them to be unwilling to adopt smart lock, and as further evidence, when we asked them to rank PIN and fingerprint against all smart lock methods in order of how secure they thought these methods were, they ranked PIN and fingerprint as the most secure ones. Security was also a top reason for people to stop using smart lock, against being the highest ranking reason according to the participants. What this showed us was that security needs more attention. We found that the semantics of smart lock, meaning the circumstances under which it locks or unlocks the phone, is rather difficult to understand for our participants. These semantics need to be clearly communicated to the users, otherwise they might perceive unexpected behavior as malfunction, which can taint their opinion of the technology. Utility was rather a divisive factor. On the one hand, it was a top reason for smart lock adopters to use the technology. They believed that smart lock could make unlocking for them easier or faster, or they could use a smart lock as a backup method of unlocking the phone in case, for example, they have forgotten their PIN. On the other hand, lack of utility was cited as one of the most important reasons for our participants to be unwilling to adopt smart lock, and they ranked PIN and fingerprint to be more convenient than any of the SL methods. What this showed us was that the utility of a smart lock and its added value was not always obvious to our participants. There were misconceptions among them as to how a smart lock could actually make unlocking faster or easy. This is one area that we believe requires further research to better understand how the utility of implicit authentication can be effectively communicated to users to increase the chances of adoption. Finally, we found concerns with reliability to be detrimental to SL adoption. Reliability was a top reason for our participants to be unwilling to adopt body, as they thought body could potentially cause accidental unlocks and pocket dialing. It was also a top reason for our participants to abandon smart lock, being the second highest ranking reason. What this showed us was that reliability requires more attention. It was known to some extent that false positives and negatives taint users' opinions of authentication systems. However, our study showed that the extent of this effect can be even higher than expected. Also, since reliability interplays with security and utility, its effect on SL adoption can be even higher than what was directly observed in our study. To make our findings more accessible, we propose an extension of the technology acceptance model, which we call SL-TAM. This model can make it easier for researchers to reason about SL adoption. Our model posits that the intention to use a smart lock is affected by three main factors: perceived usefulness, perceived ease of use, and perceived security and privacy. We found perceived usefulness to be affected by the unlocking convenience and speed of smart lock, or whether it could be used as a backup method. We found perceived ease of use to be affected by the reliability of smart lock and how easy it is to set up. And finally, we found perceived security and privacy to be affected by the actual security and privacy of smart lock, and the extent to which its semantics are difficult to understand for users. Finally, let's have a summary of the contributions of our paper. Firstly, we studied users' perception of commercial IA in a realistic setting. This shed light on important factors that attract or deter potential users from smart lock and implicit authentication. Secondly, we proposed a smart lock technology acceptance model which could make it easier for researchers to reason about smart lock and implicit authentication adoption. And finally, we found unexplored research avenues for implicit authentication on smartphones. Investigating these research topics can inform the design of future IA schemes to make them more appealing to users. This is the end of our presentation. If you have any questions about our study, please feel free to contact us using the information on the screen.